Hello, and welcome back to the Nine Nation podcast. I'm your host, Evan Nazareth, and I'm joined by the Gold Rush Robotics president, Philip Smith. And Gold Rush Robotics, otherwise known as GUR, is open to anyone of all skill levels. It's a really hands on experience to participate in robotics, engineering, and fun. So today we're going to be talking about the cool events that they do, and I'm going to let Philip tell us more about that. But first of all, what I want to know is if you could witness any historical event, what would it be and why?
I think one of a historical event that would be really cool to witness. There's this robot called Shaky. It was the first robot with AI, and it kind of stuttered around a room and could find objects. And I think it would be really cool to be there when the researchers first cracked that. I think they would have a lot of interesting comments about it.
Yep, that's pretty interesting. And of course, tied into robotics, which is something you're very passionate about. So overall, what do you think is the main mission for Gold Rush Robotics? And what do you want to achieve with your club members and with your organization?
Yeah, so our main mission is to help educate students in robotics and give them both like conceptual knowledge and practical hands-on experience to like parallel what they're learning in classes. So that's our main mission, and we try to do that through a bunch of different workshops and through just a bunch of projects that people work on.
That's awesome. Yeah, and I've seen a lot of your guys' events. I've even gone to a lot of them. SEMA one is always a cool one, which we'll get into. But what exactly is your major, and how does that? Where exactly do your passions lie when it comes to robotics? Because it is a large area. There's a lot of cool things you can do with it.
Yeah, robotics is huge. So I'm a computer science major. I'm doing the robotics concentration here at Charlotte, and I love all sides of the robot. But I specifically like the intelligence half. So that typically sits right above hardware. So hardware happens, and then the layer of stuff that I like to write, and then the higher level stuff like any AI planning or anything like that. So controls is typically what it's called.
Interesting.
Yeah.
And what exactly got you into it? Was there like you watched a TV show and you saw like a giant robot on screen and you were like, that's cool? Or just something you picked up in class? Like what got you into it?
Yeah, so I actually started doing competitive robotics when I was 7. I did first Lego League, which is a Lego robotics competition. And I've just kind of stuck with it. It's been a blast. I've really enjoyed it.
That's awesome. So what were you able to do at 7? Were you able to learn programming and stuff back then?
Yeah, Lego has some really cool tools. You build the robots using Legos, and then it's programmed using like a drag and drop interface. So it's super accessible and teachable to just about anyone. But it was cool. I did that program from when I was 7 to when I was 14. And the skill difference between the robots at 7 and at 14 were pretty distinct.
Yeah, I'm sure you were able to accomplish a lot more since your Lego days. Overall, what are how many programming languages do you think you know?
Oh, gosh. It's a very large number.
I'm scared to hear.
It depends on what I count as knowing. Having written a very basic thing it's probably in the 15 to 20 range. Having looked a little bit at the syntax, it is probably in the 30 range.
That's really interesting. Yeah. As many people probably know, when you actually mess with the programming language, a lot of them, the concepts are the same.
Yeah.
And while there's languages like Python or C++ or anything else, it's really based and rooted in the same thing. So what are some of your favorites?
I do most of my coding in Python. Robotics tends to live in either Python or C++. Generally, the way it works is you prototype in Python, and then when things need to get sped up, they get moved over to C++.
That's cool.
Yeah.
So you're also a part of IEEE kind of as
Yeah.
well. So do you want to talk about like kind of the differences between the two?
Yeah, sure. So IEEE is a professional student org. So it serves the student body by connecting with academics and other professionals, talking about things that IEEE does. So IEEE runs certifications for just about everything electrical. So Bluetooth, Wi-Fi, how many volts your house runs at, all that stuff is defined by IEEE. And so we have an IEEE student branch that helps connect students with those resources. And Gold Rush Robotics is an IEEE Robotics and Automation Society branch. So we're kind of under that umbrella. But we are much more focused on the competition side of things rather than the academic side of things.
Yeah, that's really cool. And you guys have had some really neat competitions. As we talked about, there was that sumo event a while ago, and that was just a one-day event. Everyone could like come in as like a recruiting event. And as you kind of said, all skill levels were represented. And if you had a basic interest, you were able to compete and like fight these other robots. And that was a huge turnout. So congrats to your club on that success.
Yeah, thanks. We try and run that every fall semester as part of Gold Rush. So we'll be doing one this next year as well.
Awesome.
Yeah.
And then overall, you have other competitions as well that you want to do, which are like your main focus. So do
Mhm.
you want to talk about the two that you kind of have going?
Yeah. So we compete in two different competitions run by different organizations. So one is run by the IEEE Southeast Con, and the other one is run by ASME. Both of those, the challenge changes every year. So I'm going to give a brief overview of what we're doing this year to give you an idea of what it's like, but it is different every year. So for this year, for the IEEE one, we have to find these. Do you know like what a D20 is from D&D? We have scaled up versions of those that we have to find on the ground. Some of them have magnets inside, and some of them don't. There's no visual difference, so the robot has to find them and sort them into those two categories. And then the other competition, we're given a bunch of ball bearings, steel, nylon, and brass, and we have to sort them by their type.
Oh yeah, that's really interesting.
Yeah.
A lot of the robotics competitions are based around colors and objects. Some competition items from previous years have been ducks. If you're watching our YouTube version, you can see, or marshmallows or cubes or something of multicolor facets.
Yeah.
That are pretty interesting. So yeah, being able to compete in those different levels is very fascinating, but does require a lot of different branches. Do you want to talk about like how your sub teams are kind of broken up to be able to accomplish these projects?
Yeah, for sure. So we build our entire robots from the ground up. So we have mechanical people who work in CAD and manufacturing to help us get ideas from our heads into the real world and physically made. Then we have kind of an electrical sub team that works on designing custom printed circuit boards and wiring everything up and designing how we want our architecture. And then we have a software sub team that writes from firmware level up. So we have a full robot stack that changes every year. We've been slightly tweaking and improving it, and it's pretty cool.
Yeah, that's interesting. And then I'm sure you've heard of other robotics competitions or feats. Has there been any really standout ones in recent years that have been like, oh, that was really cool, and I hope to do that someday?
Yeah, there's some really cool ones. Most of them are so like DARPA does one where it's like a hazardous recon. And so your robot has to go find things and rescue some people, and that one's really cool. But is in the robots are millions of dollars range, not robots are $2,000 range.
Yeah, yeah, it definitely scales going from Lego to college level to thousands of dollars.
Yeah.
But yeah, still all cool stuff. Okay, so in terms of other events you have different competitions and conferences and things along those lines. So I saw that you got to participate in ROSCON, which was an event I saw that was held in Denmark, and I thought was pretty cool. And I saw you were able to present at that.
Yeah.
So how often are those kind of events scheduled? And was that something you were able to do through Gold Rush Robotics on your own through your major? Like how would you get to Denmark? I feel like that's a really cool feat to be able to do.
Yeah. So conferences like that happen all the time. There's 3 main robotics conferences that are like huge world traveled conferences. ROSCON was one. This year it was in Denmark. There's ICRA, which this year is actually in Atlanta, and I'm going to try to go to that as well. And then there's also there's a couple other ones. For the one ROSCON, me and a friend on Gold Rush decided that we would apply to present there. We figured there was no shot they'd let us in, and then they were like, "Yeah, we'd love to have you give your talk." And we were like, "Oh, okay. I guess we need to like figure out how to get to Denmark now." And so that was an adventure, but we took some slightly sketchy flights and got to Denmark and got to present in front of a room full of like professional robotics engineers, which was a little terrifying, but it was a super awesome opportunity. We got to meet a lot of cool people.
Yeah, I'm sure that was definitely a very interesting thing, especially because because sometimes you do know you never know what's gonna work out.
Yeah.
So applying for those neat opportunities is, I'm sure, really fun. Did you have any big challenges overall between any of the competitions you had during that talk? Anything that kind of stuck out to you that you had to overcome? Obviously your travel, but
We always have big challenges. I mean, that's part of the fun. We take on a little bit more than we can chew every year, just in order to try and learn more and grow. Some big ones, like for the duck you held up earlier,
yeah,
those things were very annoying to try and deal with. We were still working on trying to properly handle them. Like the week before the competition, we were in the lab every single night trying to get that thing working. That was a interesting challenge.
yeah, I'm sure there's a lot of different little kinks that come along the way. And as you probably know, all the subsystems have to work not only independently but together.
Yep.
And sometimes there's a difference between where the holes need to be placed or one line of code.
Yeah.
So I'm sure that gives you errors and things that don't necessarily all work correctly. So it's just being able to figure that out. But yeah, overall, do you think there's any big myths or misconceptions about the robotics club or the robotics industry?
I do. I think a lot of the people I talk to say that they think it's super cool, but that they don't have enough experience, or that, they would just be slowing us down. And I think that is really not correct. We are super open to all experience levels. We have a bunch of members now who are senior members who are graduating that came in knowing absolutely nothing about robotics or engineering. We have multiple not even engineering majors who are there because they think robots are awesome. And they've been able to pick up skills and are working on the robot.
Yeah, that's fascinating. So what do you think are kind of your areas of specialty when it comes to working on the robot? Like what personally are you good at, and what's your go-to?
Yeah, so my go-to is the last mile. So we call it integration. It's when you've got your subsystems, everything theoretically works on its own, but now you need to get the hardware to work with the electrical to work with the software. And that last final push to get everything working together is when I spend most of my time with the club.
So yeah, kind of what we were saying, that putting everything together, that integration piece. Interesting. Yeah, being able to solve those problems on the fly or long term is kind of interesting as well. And then you guys this semester, this year, recently got to go into the Super Fab Lab. So how is that? What are the cool tools there? What are your favorites?
Yeah, so the Super Fab Lab is awesome. It's a new makerspace that's opening up on campus later this semester. It's part of a global network of Fab Labs trying to move manufacturing knowledge from companies to the everyday person. So some of the really cool tools for us as a robotics team is there's a water jet in there. And so the way a water jet works is it just shoots pressurized water, and then it can cut through anything if you wait long enough. It's like how rivers have made the Grand Canyon. If you wait long enough, it'll cut through just about anything you want. So we can cut aluminum plates to be exactly our specification for our robot.
Yeah, that's really cool. Water cuts through everything, and it's neat that they're able to engineer something that can just slice. But yeah, overall, I guess, what do you like within that? What's your favorite type of 3D printer? There's obviously a lot of different kinds. There's PLA, there's resin, there's chocolate, there's food, biomaterials. A lot of people don't know about that. You can 3D print a lot of different things.
Yeah, it's super cool.
But yeah, what are you into?
I really so PLA is great as a prototyping material. It's super quick, it's super cheap, so you can quickly get an idea out of your head into the physical world. But once you actually start needing things to last and be rigid, I like resin or nylon. So that's another cool thing the Fab Lab has is we actually have an SLS nylon printer. So it's got a keg of powder, and it shoots a laser in and selectively solidifies a part. And then it sinters it by cranking it up to 500 degrees Fahrenheit and melting any other debris away. And then you've got just your solid nylon part.
Yeah, that's interesting. And then for our junior design project, which we're working on right now as mechanical engineers, we're building a robot as well, trying to go through an obstacle course and lift a soup can and actuate that and all that. So one of the things we were just working on was printing all of our parts in PLAs to just prototype it. And we think we're going to add in some resin because, as you know, it's very precise when it comes to that. So there's different uses to each of the different materials, and then obviously there's some really cool ones like chocolate or cheese or other things as well.
I would love to 3D print with cheese.
Yeah, my roommates just bought some 3D printers and they were like, oh, we want some chocolate ones now too.
Yeah.
Cool. God. But yeah, so that's a little bit about that. Would you like to talk about any of the community events you kind of do? You guys do a lot of different things between open houses and volunteering to be able to fund your club and work on sponsorships. So you want to talk a little bit about that?
Yeah, sure. So we love learning about robots. Robots are expensive. So we volunteer, and some of these events pay student orgs to volunteer at a lot of these things. We have been at basically every engineering open house since I've been here. We go to all of the club showcases, all those things. And then we help run, they'll send out an email. They'll be like, hey, we need help running the International Fest. Can you send us 10 volunteers? And we're like, yeah, we got you. So we do a lot of those things. And then things that are more focused towards our club, we typically run, this last year so far, we've run 19 different workshops and events. So starting with what you were talking about earlier with the sumo event, and then we've run 3D printing events, soldering workshops to teach people how to solder. We've run some modeling and design workshops. We've run, and then just some fun ones. We ran blanking, but we've run some fun workshops as well. Yeah.
Yeah, I was looking through a lot of the ones you had, and you do run a lot of workshops. I saw ones on Onshape, which is a design software, Raspberry Pis, Mechanism wheels,
Yeah.
ton of different things across the board. And I thought that was fascinating that you're able to teach your club members laser cutting. So pretty much anything that's used in any stage of the design process, which is really exciting. Do you want to talk a little bit? Obviously, each design cycle is different for everything, but how exactly do you think is your average timing about how you want to go about your robot?
Yeah, so we get our challenges. We typically start thinking about them over the summer because we typically get them at the end of our competitions. So we start thinking about them over the summer, and then fall comes around and we start prototyping. I love prototyping. It's probably my favorite part of the process because anything goes. You're taping toothpicks together. You're using popsicle sticks and rubber bands to try and like get your mechanism out of your head and see how well it works just a little bit. And then once we kind of have our ideas locked down a little bit through prototyping, we move into CAD. And so we'll design and 3D print. And that's kind of the second stage of our prototyping. It's still prototyping because it's very quick and learning rather than aiming towards a final design. Then around heading towards winter break, we try and have our robot finalized. That never happens. It's how it goes. But so our design cycle on the hardware side is typically fall semester, and then spring semester is just tweaks and refinements is the theory. Alongside, while hardware is doing that, electrical looks at our control system and decides, okay, based on the things we're planning, we know we're going to need 5 motors, we're going to need 12 servos, we're going to need whatever else. So we need a system that can handle those things. And so they'll work on designing PCBs and getting those ordered, getting those tested, prototyped, all that fun stuff. And at the same time, the software sub-team will be working in simulation, working on writing drive-based code, things like that that's reusable every year. And then as soon as we have code from the mechanical sub-team, we'll start having CAD from the mechanical sub-team. We'll load that into our simulations as well and start being able to do full robot sense, which is really cool.
Yeah, longevity is another piece that I think not a lot of people tend to think about as actively, as when it comes to thinking about a design, being able to give that to other people going forward. And so I like that your club does that. Rocketry Club does that as well, to be able to pass on the designs and stuff that you can, so everyone's not recreating everything from scratch every single year of comp. So that's exciting. And then on top of that, what do you think are if you were given a task to design a robot, what do you think are you looking at first? Like when you think I need to make a robot, what are the most important areas and what do you like to think about?
The most important area is budget. Once you've got your budget locked down, then timeline. Because there's a couple ready-made off-the-shelf components that you can grab, but typically they'll perform worse than something custom designed for your job. So looking at price and money will tell you what of that you can do. Then I like to sit down and kind of sketch out just like goals and interactions. So to give an example, if you've got cylinders that you need to pick up and stack, then start looking at okay, how far off center can the stacks be before they topple? How much can we rotate the cylinders, that kind of thing. And then start going into prototyping of okay, how do we rotate our cylinders to make sure they're always vertical? How can we precisely place our cylinders, that kind of thing.
Yeah. So as we kind of talked about, there's a lot of different skill levels and ability when it comes to robotics. So what advice would you give to someone who's new, who really wants to learn? They don't know anything. And that honestly, I would say applies to a good amount of people. A lot of people are interested in robotics and want to get into it, but where do you think are some good websites to learn the basics of coding or learn how to CAD, softwares you recommend, stuff like that?
Yeah. So learning how to CAD, the robotics team uses Onshape. I love Onshape. Onshape has a free license for students and a free license for hobbyists as well. And they have an awesome resource. Learn.onshape.com is just a bunch of Onshape tutorials. So those are super awesome. It's a great tool. It's used in industry. As far as coding goes, The best thing, and coding and just robotics in general, I find like the best thing is just dive in head first, which is a little terrifying, but just pick a project and be like, this is something that I want to try and do. And I mean, typically you want to think about scope, right? Like you don't want to decide that your first robotics project is going to be a, AI robot that's going to help you in the kitchen. But, making a robot that opens your blinds might be a good first project where you have to think about, okay, how do I want it to actuate? How do I want to design this? How do I want to control it? How am I going to power it? All that kind of stuff is new things that you need to think about. And the best way to do it is just through projects.
Yeah, I would say that really goes down. Really anything that comes with creativity is learning to accept failure and just being able to power through, whether it's art, engineering, whatever. It doesn't matter. The point is you got to be able to get used to the hurdle of being able to jump it. So kind of going into that, how has your perspective kind of changed on robotics based on the experiences you've had as a leader now kind of in this program?
Yeah, I think a big thing for me was shifting, like you were talking about, needing to fail fast and shifting from it being me who's failing to it being me guiding people who are feeling bad about failing. I don't get that much hands-on time with the robot that much anymore. Most of my time is spent doing admin and logistics, which is how it all goes once you get big. But so I'm doing a lot of more guiding rather than actually creating. And that's been really interesting to like see the way that people's brain works. I really like handing someone a problem and watching the way they try and tackle it is really neat.
Yeah, because you're about to graduate this
Yeah.
semester, so you're having a very different perspective on things than a new student would. So kind of going along with those lines, what do you think are like some of the cool experiences you've got to have through your various internships or like research opportunities?
Yeah, I've had a lot of really cool experiences. I One summer I worked in Pittsburgh. I worked at a robotics company that made robot arm joints. And then the summer after that, I did some research, and I worked on point clouds, which are you can capture 3D space by just mapping a bunch of little points, and eventually you get close enough to an approximation of the space around you. And then the summer after that, this last summer, I actually went and worked at a construction robotics company that has a robot that drives around and prints onto floors to help construction teams out. I've also done OUR during the semesters. OUR is the Office of Undergraduate Research. They have a really awesome program. Tons of professors in all sorts of different fields and interests. There's a couple different robotics professors. I've worked with 2 of the 4 that do robotics through OUR. Various different projects. I'm third name on a paper through that. A couple other neat experiences.
Nice. And then kind of going into the future.
Yeah.
Yeah, scary. Now, what do you want to accomplish in your remaining term as president? What do you want to do in your personal life? Things you want to do past college, stuff like that.
Yeah, so finishing out this year, my goal is to try and like leave the club in the best state it can be going forward. We just had our elections, so we've got our next year's executive board. They're all super awesome. I'm super looking forward to see what they do. I'm also doing some work behind the scenes with the college. They're trying to make robotics a bigger focus because robotics is super cool and awesome, and they think it's going to be even bigger going forward. So I've been helping like look at course syllabuses and help design curriculums for more specific robotics concentrations, and that's been a super awesome experience. Me personally, after I graduate, the goal is to go get a PhD in robotics. And enter either industrial R&D or become a professor somewhere.
Yeah, that's interesting. I was about to ask if you wanted to become a teacher because I feel like that's something I feel like you would enjoy.
I really enjoy teaching. Yeah, it's a good time.
But yeah, where in general do you think the future of robotics is heading? Like, what do you think are some really cool projects that could be undertaken by robots, like underwater stuff, like in the oceans, to be able to do more exploration there or space? Like, what do you think is like some cool like applications that are interesting to you?
Something that is really cool and interesting to me, the 2 main ones that super interest me are like search and rescue and hazardous regions and space. Space is really cool because there's some people working on the idea that we just send a spaceship full of robots up to Mars and we let them kind of work on their own thing for a couple years, and then we have a habitat ready for us when we get there, that kind of thing, which sounds super cool and awesome. Also, hazardous areas inside nuclear reactors, search and rescue where humans can't go. All that kind of stuff is just like awesome use cases for robots.
Cool. And then as far as present day stuff, what's like the coolest robots you've ever seen, or kind of like some funny experiences you've had in the process of creating some stuff?
Yeah, the coolest robot I've ever seen in person is probably some of the robots I saw at Roscon. There were some companies there doing demos. Unitree was there, and they have a really cool robot dog. The way that their software works for its gaits, which is how it walks, is pretty unique among the other robot dogs. And so it allows it to do some really neat things. Like it can jump in a circle, so like it jumps and spins at the same time, and some other really cool things like that. It can do a flip. It's like, okay, wow.
Nice. And then go back to the other half of that question. Do you have any funny stories from like things you've worked on that just have not gone right? Like an arm that just keeps hitting itself or something like
Yeah. I mean, arms that hit themselves, robots that hit me,
Yeah.
it's all par for the course. For this, one of the research projects I was working on, I was trying to get TurtleBots to, TurtleBots are like a basic education robotics platform. And I was trying to get them to recreate a thing we had modeled in math, and our math said it was supposed to go one way, and I was trying to get the robots to behave in a way that agreed with the math, and they just would not. And I kept tweaking with things until eventually I had a problem where they both just decided they were going to run full speed at each other, and then they flipped, and that was very
Like
exciting.
turtles.
Like turtles.
Wow. They live their intended purpose. I'm glad. Cool. And then kind of going back to your club members, have you ever seen any of your members who have participated in GER, how it's like shaped their career further
Yeah,
beyond that?
absolutely. We have so some of the members who have graduated since I've gotten here, a decent number of them have gone into robotics or industrial automation. I know I have a couple friends who joined their freshman year because they were like, well, this is an engineering club and it seems somewhat interesting. And they weren't that interested in robotics. They thought robots were cool, and now are planning on fully going into robotics. A couple of my friends who are also graduating this semester have robotics jobs lined up and things like that. Super cool to see.
Fantastic. And then lastly, what do you think has been some of the most rewarding experiences you've had, or like things you appreciate while your time at the university as you are graduating?
Yeah, I think the most rewarding thing for me, and going back, I love teaching. So watching people I've taught succeed is super rewarding. I TA for a couple robotics classes, and teach a bunch of workshops for GER and all that fun stuff. And so getting to watch like my students, I guess, like go off and create awesome robots is super cool.
Thank you. And then overall, what would you like people to take away most from our conversation today? Anything about robotics in general, advice?
I think that robotics is super cool. I'm not biased.
Not biased whatsoever.
But that also it's super open. We're always looking for more people, more talent, in all sorts of areas, and every background means a different way your brain thinks, and so it means a potential slew of solutions to problems in a new and unique way.
Fantastic. Yeah, thank you so much today. So that's our time for today. Thank you again to Philip, truly, for sharing your experiences. Super interesting stuff. A lot of upcoming things. As an unbiased representative, I think the work you're doing is great. So yeah, be sure to tune into our next episode, and follow at @Niner_times and at @the.nazareth on Instagram for updates on more episodes. Yeah, thank you to our listeners, and be sure to check out our next episode on Wednesday. And if you're interested in being on an episode, please reach out to me by email or text. Stay tuned and go Niners.
Go Niners.